Okay, so let's proceed now with our solution. Now, let's apply this Euler's equation sa ato ang general solution. So we have so to e to the positive or negative I omega t is equal to cosine omega t plus minus I sine omega t. And then so to we have our general solution nga u of t is equal to g1 e to the I omega t plus g2 e to the negative I omega t. So ato lang i-substitute, we have g1 times quantity cosine omega t plus I sine omega t plus g2 as quantity cosine omega t minus I sine omega t. Okay, let's just distribute. We will have g1 cosine omega t plus I g1 sine omega t plus g2 cosine omega t minus I g2 sine omega t. Ito lang silang i-factor, no? Let's combine like terms. We'll have ang cosine, we'll have g1 plus g2 times cosine omega t. And what else? Plus g1 minus g2 I sine omega t. So, nabot na ta diri. So, may next na to buhaton. Let's solve for g1 and g2. No kaning arbitrary constant. So, natay initial value, no? Or initial condition. So, man itong initial condition? Nga, at time is equal to 0, atong u of 0 is u naught, or initial displacement. And our u dot of 0 is equal to u dot naught. Ano lang. So, to apply our, so we have our u of t is equal to g1 plus g2 cosine omega t. So, omega times 0, because the time is 0, that is cosine 0. Plus, we have our g1 minus g2 times I sine 0. Now, cosine 0, this is equal to 1. And sine 0, that is equal to 0. So, we are left with u naught is equal to g1 plus g2 times 1. Or simply, g1 plus g2 is equal to u naught. So, let's say this is our equation 1. Now, let's proceed sa itong second initial condition. Di ba sa to? From the given initial condition nga time is equal to 0 daw, atong u dot 0 is equal to u dot naught. So, we have, di ba, u of t is equal to quantity g1 plus g2 times cosine omega t plus we have the I sine, sorry, we have the g1 minus g2 times I sine omega t, di ba? Let's just differentiate this. We'll have u dot of t is equal to omega g1 plus g2, negative omega rather, sine omega t, and plus we have our omega again, omega times g1 minus g2 I sine omega t. So at t is equal to 0, we will have u dot naught is equal to negative omega times g1 plus g2 times sine 0 plus omega times g1 minus g2 I sine times, sorry, now this is not sine. Kaya ito naman yung differentiate. this will become cosine rather. So we have a cosine here, cosine omega t, and I cosine 0. So sine 0, that is 0, and cosine 1, that is 1. So nata u dot naught is equal to I omega times g1 minus g2 just times 1, or simply that our g1 minus g2 is equal to u dot naught over I omega. Let's say no, this is our equation 2. So i-rewrite lang na to. We have our equation 1, which is equal to g1 plus g2 is equal to u naught. Our equation 2 is g1 minus g2 is equal to u dot naught over I omega. Now we can substitute this to ang kuan. Governing equation 4 and damp nga kuan, free vibration. So we have u of t is equal to g1 plus g2 cosine omega t plus g1 minus g2 I sine omega t. So we'll have u of t is equal to, so our g1 plus g2 that is equal to u naught. So may manalo na siyang u naught cosine times cosine omega t plus our g1 minus g2 that is u naught over I omega. So natay u dot naught over I omega times I sine omega t. Now, makancel na nato ang I because na I sa numerator and denominator. Then, finally, we arrive at our solution, general solution sa toang equation of motion for an undamped free vibration response that is equal to u of t is equal to u naught or initial deformation times cosine omega t plus u dot naught over omega times sine omega t. So this is our general solution sa kuan sa equation of motion of the free and damped vibration response. So kuha lang tagamay no from this formula. So wala na tong C kay undamped man. We arrive with a general solution nga u of t is equal to u naught cosine omega t plus u dot naught over omega sine omega t. Now, how about if damp ang condition? So, let's discuss that on our next video.